Welcome back everyone. Today, we will talk about heat capacity and specific heat capacity. Let us begin with internal energy. Internal energy is the sum of kinetic energy of particles due to the motion of molecules and the potential energy of particles from the intermolecular forces between them. The internal energy increases when the substance is heated. But why? As heat is applied, the molecules will gain kinetic energy, increasing the material's temperature. Additionally, heating will increase the molecule's potential energy. This is due to the intermolecular bonds becoming weaker. This may result in a change of state at a certain temperature. Every substance has a heat capacity. But what is heat capacity? The heat capacity of a body is defined as the amount of heat required to raise the temperature of the body by 1 Kelvin or 1 degree Celsius. The SI unit of heat capacity is Joule per Kelvin. We can use heat capacity to calculate heat energy as shown here in this equation, where Q refers to the heat energy. C refers to the heat capacity and delta theta is the change of the substance's temperature. We have another term called specific heat capacity, which is defined as the amount of heat required to raise the temperature of 1 kilogram of a body by 1 Kelvin or 1 degree Celsius. It uses the SI unit of joules per kilogram per Kelvin. We can relate heat capacity and specific heat capacity by understanding the heat capacity as the product of mass and the specific heat capacity. We can use specific heat capacity to find the change in heat energy of a substance by using his equation, where Q is the heat energy of a substance, M is the mass of the body, C is the specific heat capacity, and delta theta as the change in temperature. So what is the difference between heat capacity and specific heat capacity? The heat capacity of a substance depends on the type of material and is dependent on the mass of the body. A substance with a lower capacity suggests that less heat is required to raise a unit temperature of a body, suggesting it is a good conductor. However, we should not use heat capacity as a good indicator of thermal conductivity, as the mass between substances may vary. For specific heat capacity, it also depends on the type of material. However, unlike heat capacity, it is independent on the mass of the substance. For a substance with a low specific heat capacity, it absorbs less heat to raise a kilogram of mass by a unit temperature. Hence, we can say that most metals have low specific heat capacities. This is a better indicator of thermal conductivity as compared to heat capacity alone. Did you know? Water is cheap and has a high specific heat capacity. Water can be used to cool car engines and to cool central heating systems in industries as they take in a lot of heat without reaching a very high temperature in a short time. Now, we have used heat capacity and specific heat capacity to calculate thermal energy. Before we move on, let us recall the concept of energy changes. Recall that work done by heat energy by a substance can be written as the product of power and time. We can also substitute power as the product of voltage and current. This gives us the formula as shown. These formulas are useful for electronics that convert electrical energy to heat energy. Now, let us introduce some experiments which can be used to determine the specific heat capacity of a metal or liquid. The calorimeter method and the electrical method. The calorimeter method can be seen in the diagram as shown. The copper calorimeter has a small specific heat capacity. Heat transfers from the heated metal to the cooler water. In the calorimeter, the heat lost by the heated metal is transferred to the cool water and the copper calorimeter. This can be shown in the equation below. This can be further broken down into this equation. Take note that since the initial temperature of the metal is higher than the final temperature, we use initial minus final and not final minus initial. The electrical method is shown in the diagram below. Heat is provided by a power supply to an immersion heater. The electrical method is consistent as it is used for an even distribution of heat for a period of time. In the electrical method, the electrical energy by the power supply is converted into the heat energy received by the object. We can further break it down into the following equation as shown. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye.